Alright, we're looking at a little extra practices here on practice worksheet 3-1. We're in unit 2. We're talking about systems of equations and how we can classify systems. Remember, dependent means that the two lines are right on top of each other. They have the same slope and the same y-intercept. They're the exact same line. They are dependent systems. Independent systems cross in one place. They have different slopes. That's all we need to know. If they have two different slopes, they will definitely cross at some point. If they're inconsistent, there should be two parallel lines. This means they have the same slope and a different y-intercept. So as long as we have to find the slope anyway, we might as well put each of our equations in y equals form, y equals mx plus b. And that'll tell us the slope and the y-intercept. Then we can look up here and figure out which category it falls into. We've done some of these in class and practice, but let's do a couple extras just so that we know we've got it. I'm going to skip down to number 9. There's some other work in case you need to see some of these things up here. But number 9, I see one of them already is in y equals form. The other one, we just need to subtract x from both sides to cancel those out. So I have y equals 11 minus x and y equals x minus 5. Now what I noticed, this one has a positive slope, and if there's not a number in front, we can think of it like having a 1. So this is a positive 1, and this is a negative 1. So this one's slope is 1. This one, the slope is negative 1. And because they have two different slopes, this means that we have an independent system. I can classify it without even having to graph it on my calculator. If I skip down to a different one, I'm just going to pick number 11, hoping that, actually let's go ahead and do number 12. I'm trying to get y by itself. This second equation is a little bit easier. So if I just simply divide both sides by 2, I get 5 halves x, or 2.5x, 2.5 there. This one takes a little bit more to do. So to get that x by itself, I need to move either one of these two things to the other side. There's a 0 there right now, so I won't have another number. If I move that 10 to the other side, 10y, I'm going to add it to both sides. This is nice because it makes it a positive y then, so I have 25x equals 10y. I'm trying to get y by itself, so I'll divide each side by 10. 25 divided by 10, well, I can put that as a fraction in lowest terms. Looks like 5 is divisible by each of those numbers. 10s cancel out. And check it out. We have a line where each of the two slopes are exactly the same. The number in front is the same. If I have two of them that are exactly the same, and neither of them has another number, there's no other like anything, so we can have it like a plus 0 if we wanted to. They're not adding any y-intercepts, so each has the same slope, same y-intercept. That means each one of these is a dependent system when we put them together. Yeah, I spelled that totally wrong. Alright, so we have a dependent system. Up here I have a few examples of independent and inconsistent, so if you need to hit pause and check those ones out a little bit further, you can do that. But I'd like to flip over to the back side. Over here we have, we're looking for solutions, and a solution to a system looks like ordered pairs unless they're on top of each other. Dependent system is going to be an infinite number of solutions because they're anything along that line. Inconsistent are going to be parallel lines, they have no solution. Two ways to go about it. If we have y equals, we can graph. Or if we have one variable by itself, we can use substitution and plug into the other. So I'm going to randomly pick number 18. This one looks like it might be fairly easy to get one of the variables by itself and use substitution. So if I get, let's get y by itself up here in this first one. I'm just picking any of those variables would be fairly easy. They all have a coefficient of 1. But I'm going to get y by itself by subtracting x from both sides. Negative 1 minus x. And now I'm going to use substitution and plug this in place of y in the other equation. X minus, open parentheses, negative 1 minus x, close parentheses, equals 3. Watch that subtraction out front because it distributes inside there. And I have an x minus negative 1, that gives me a plus 1. And minus negative x, subtract x, means plus x. Combining like terms, 2x on this side. Moving that constant to the other side gives me a 2. I'm going to divide both sides by 2 so I can get that x all by itself, and I find out that x equals 1. Now that I know that much, I can take this x equals 1. I'm going to start my ordered pair because I have half an answer right there. But I can plug it now in up here and see what my y would equal. So I'm going to plug it into this first one. I know x is 1 plus some unknown y value equals a negative 1. If I subtract 1 from both sides, I get y by itself equaling negative 2. If you have something up here like 16 is, we could take all of this here and we could plug it in place of y. It's already by itself, so we could simply just put it right in place there. Now you may be peeking ahead and you may be seeing something like number 23. And you may say, uh-oh, fractions. But both of these have y by themselves, so let's just turn to our calculator. Type it into our calculator and let it do the hard work and find our intersection point for us. So I'm going to type this in. I'm in my y equals. I'm going to put fractions in parentheses. Please be careful, that's a negative 1/4 x minus 3. There is a difference between a negative number and subtraction on your calculator. So that negative 1/4, I use the negative button right here. The subtract 3, I use the subtraction button. Go take a look at that graph, and here we clearly see that these lines intersect. Sketch that graph. Yes, yes, this is how you show work when you're using your calculator. And I see we have an intersection point there. To find it on my calculator, don't trace, don't estimate, calculate. Second trace takes us to the calculate menu. Intersection point. Get as close as we can to that intersection point with the cursor. Enter, enter, enter. And it tells us that intersection point is at -8, -1. Hope that was helpful to see a few more examples and how we could do practice 3-1.